Okay, thank you very much for coming. So today we'll be talking about one topic here, just one small topic, but it's very useful for your OSPF network. That topic is called BFD here. BFD means Bidirectional Forwarding Detection. So it's kind of things or protocol for detection, which can speed up the process for checking the link failure. Okay. Yeah, this is our agenda. We do the introduction and then review some prerequisite concept, just in case if you are new to this webinar, and then discuss the OSPF and BFD. If you already know, and then this will be fast. Okay, you can just jump into the BFD if you already know the OSPF stuff. Okay, so for those who are new, we are GLC, Garda Lintas Cakrawala. We are based in Bandung. We are doing training and IT consulting. We do MikroTik, Ubiquiti, Linux, and then we do some programming. And then my name is Achmad Mardiansyah. I'm based in Bandung, Indonesia. Yeah, I'm a MikroTik user. Most of many IT technology user, including MikroTik, Cisco, Linux, database, and then programming stuff. Yeah, many things. Okay, this is our experience. Okay. Oops. Why is it like this? Oh, okay. Yeah, never mind. Can you still see it? Yeah. This is our experience, mostly related to IT networking stuff, mostly ISP. Thank you very much for coming. So if you don't mind, you can introduce yourself in the group chat. Yeah. We assume you already know several knowledge here, like TCP, IP, MikroTik, of course. Yeah, this is about MikroTik and routing protocol, and then routed protocol. Yeah, just review. We already know 7 OC layer. On each layer, we have protocols, and then the protocol is a rule for communication. Okay. And then we have encapsulation. So what we send is not on application is not really what we send on the networking device. Okay, so what you type here is hello, but you actually send more than just hello, because there are lots of overhead from other layers. Yeah, those overheads are important to make sure that your message is arrived to the destination. And then during the way path to the destination, we have router and routing. Router is the hardware, routing is the process for selecting path. Okay. And then as a network engineer, when you do network things, usually you set up, you draw a topology, how the network looks like physically. So it's called physical topology. Right, so it says, okay, this router is here, this router is there, and then this router is connected via switch, so on and so forth. And then we set up a logical topology, which consists of layer 3. So this subnet connected to this subnet, and then those subnet are connected through a router. Okay, so this is how the routing looks like, the routing table looks like. Okay, so only 2 columns. You want to go to a certain destination, and here's the gateway. Okay, and then here's example. If you already know how it works, and then yeah, you should be able to understand this one. And then this is where the routing lookup happens. Yeah, so if you have routing lookup, if you have a routing table like this routing table is read on this stage. Okay, on this this stage. So we have input interface, and then the pre-routing, and then routing decision, and then forward, and then post routing, and then the packet out. from the output interface. So this input interface and output interface can be same interface. Yeah, so both of them are either one, for example. Yeah, it's not a problem. And then how routing works with the administrative distance. Yeah, so this is how it looks like. Okay, so on the left here, we have a gateway, and then we have a destination. Yeah, so this is our gateway, and then this is our destination, and then here's our distance. You can see. So we are going to city number 2, and then we have 2 gateway here and here, and then we have distance. So what we prefer is the distance that has lowest compared to others. So it means that we are picking the left turn. Okay, so this analogy goes to this table. Okay, so this is how the routing table looks like. Okay, and then if you check the routing table and router with IP route print, okay, and then it's a similar concept. Okay, you have a destination, you have gateway, you have distance. Okay. Yeah, this is administrative distance. Yeah, yeah, from others routing protocols. Okay, that's very depends on the vendor. Okay. Yeah, this is a static routing. Okay. So static routing means you have to log into every router and then configure them manually. With dynamic routing, all routers will talk to each other and then they will communicate through routing protocol. Okay. And then you need to know that asymmetric routing is done one way. Yeah, so there is no guarantee that outbound path is similar to the inbound path. Okay, so once you already know them, we talk about the OSPF. Okay, so OSPF is dynamic routing protocols. Yeah. Yeah, it's a link state Dijkstra algorithm. It's IGP. Okay, lots of people is using it. Yeah, requires more processing compared to RIP. Yeah. And then here we have autonomous AS number. Okay. So AS number here, it's a collection of routers and network under one administration and then identified by number. Okay. So if you have AS and then what's your AS number? Okay. And then your IP address must be unique related to those numbers. Yeah. And then given by IANA, yeah, it's a international organization which govern the IP address, and then they delegate the authority to RIR, like EPNIC, LACNIC, EFRINIC, RIN, RIPE, NCC. Okay, and then inside the AS, so for example, this is your AS, and then you are running the IGP, yeah, Interior Gateway Protocol, like RIP, OSPF, ISIS, ERGRP. Okay, so that's the concept. And then this is how OSPF works. So you configure OSPF in one router, you log into one router, configure OSPF, you log into other router, configure OSPF, and then make sure they can communicate, right? And then here's the thing, yeah. So this is how actually define how OSPF works, yeah. So here's retransmit interval every 5 seconds, transmit delay, hello interval, and then here's the dead interval. Okay, so as you can see here, every 10 seconds router A and router B is sending hello packet, so like a ping. Okay, so A send hello, hey A router 1, sorry, router 1, router 2, make it like that, yeah. Router 1 send hello to router 2, another 10 seconds, another hello, every 10 seconds, okay? So if 40 seconds, Okay, if 40 seconds. So you ping 1. Okay, for example, you ping 1 time. Yeah. Okay, so I think a maximum is 4 or 3. Yeah. So if router 1 send to router 2, okay, send hello packet and then no reply. Send again, no reply. Send again, no reply. Okay. Send again, no reply. So 4 times in consecutive no reply, it means that the link is broken. So it means that the OSPF will tell, oh, okay, this link is not available anymore, so do not send traffic through this link. Okay, that's how, even though it's still on. Okay, because sometimes here's the things how OSPF works. Okay, OSPF will continuously send traffic as long as the interface is on. Okay, so for example, the router connected to a switch port 1, and then connected to other routers using port 2. Okay, let me get other. Here, for example, okay. Yeah, so this is port, oops. So this is port 1, okay. This is port 2, this is port 3, okay. So router 1 connect to this one, router 2 connect to this one, okay. So they are running OSPF, okay, and then they should communicate to each other. So the OSPF on router 1 will always on as long as this link is on, okay. But sometimes we have problem here. Okay, the switch is broken or hang or whatever, but the electricity signal is still on. So OSPF here is still alive. Here is still alive. Okay, you get my point, yeah? Okay, so that's why it's not the OSPF there is not dead, still sending traffic to that interface as long as the electricity signal on that interface is still alive. Okay, so router 1 send hello to router 2, send another hello to router 2, send another hello, send another hello. If there is no reply for 40 seconds, okay, 40 seconds no reply, and then I will not send through this link. Okay, that's how it works. Okay, so that parameters, those parameters are defined here. Okay, so this is important parameters for OSPF, yeah. So this is write transmit interval, delay, hello. This is hello interval, and then this dat interval, which determines how OSPF is dead. Okay, so if we already 40 seconds, no reply at all, I will not send. That's how OSPF works. Now, here's the issue. The dat interval 40 seconds, yeah. What was the issue? Because nowadays people are screaming, yeah. If they don't have any response quickly. So we need to have a way, instead of waiting for 40 seconds, yeah, we need to speed up. Do you see the issue? Yeah. You understand the issue, okay? Yeah. So again, 40 seconds is too long. Yeah, okay, it can detect the link is not up, yes, but it's too long. How to speed up? By BFD. Okay, so with BFD, it is very, very responsive. Okay, so at least you know how OSPF works, okay, by using the hello packets. Okay, and then we decide the link is broken or not by, okay, if the interface is off, okay, no electric signal at all, or when the dead interval is reached. Okay. This is about OSPF area. Okay, so you know OSPF is a hierarchical protocol. Is a hierarchical protocol in terms of area. So there must be an area 0 here. Okay, and inside area 0 we have non-area 0. Okay, so these are terminology: neighbor, adjacency, area. Yeah, so area is a collection of networks. Okay, and then here are the OSPF routers. Okay, we have ASBR here, and then we have ABR, this one, and then internal is inside here. Okay, so in our topology, we will do it like this. Okay, so all of them are in one single area. Okay, so all of them are in a single area. So this one is ASBR. Okay, so all of them are in one area, one single area. Okay, so how can BFD helps? Yeah, so this is BFD. Yeah, it's a very simple protocol. Yeah, operating on interface, either a physical interface or non-physical interface. Yeah, like this one or this one. Okay, independent from media. So it doesn't matter if you use wireless, fiber optic, Ethernet, yeah, whatever. So it's independent. It's independent from media, independent from data link, independent from routing protocol. So BFD can be used for BGP as well. Yeah. So how it works? Checking bidirectional network reachability. So you say here bidirectional. So it means that it has to configure in both interface. Okay, as additional link failure detection. So layer for information, it uses UDP, port here, this port, and this one. Okay, for RFC, here they are. Okay, so how it works? Well, it's very simple. So on that interface, you just activate this BFD. Well, currently I don't see this information on router OS 7. So if you use version 7, I don't see any BFD there. But in version 6, yes, there is BFD. Okay, so on router 1, you tick BFD. On router 2, on that particular interface, so this is the interface, right? You tick the BFD, and then that's it. So they will communicate. If link is down, for example, this is IP address, yeah? So you put an IP address here, and then you disable the IP address. Okay, that's how you simulate when the link is down. For example, if IP address is down, then how can you send to the gateway? IP address that attached on the interface will be used as a gateway, right? And then if you disable the IP address, how can you send the traffic to the gateway? Yeah. So this is what you can do. You put an IP address and then disable the IP address so that you cannot ping the IP address, and then check how responsive it is. Okay. So, oops. Yeah, I think that's all. Yeah, it's very, very simple trick. Yeah, I use BFD in my network. Yes. Whenever it's possible, I just turn on the BFD. Yeah, there was some bugs with BFD, but they already fixed it. Okay, so no problem. Yeah, if you have any questions, and then please let me know. If you're interested, come to our training, and then we will set up a schedule for you. And then here's the end of slides. If you have a feedback, here, if you have any suggestion for new topic here, And then further events is available on our website, Facebook available for updating news, and then slide will be available on Slideshare. Discord is a group for Indonesian. Recording will be available on YouTube. Okay, I need to fix this one here, but when I do here, it looks like it's okay. Okay, later when I upload to the Slideshare, I will update. I will yeah, fix the thing here. Okay. Any questions? Oh, okay, I get. Is it okay to run OSPF between router V6 and V7? Yes. Yes, it's possible. Yeah, we did the previous webinar as well about that. Yeah, so one side is version 6, other side is version 7, and then they can work well. Yeah, again, for a BFD, it has to be from both sides, so not from one. Okay, so both sides must run BFD. Okay, not only one side. Any other questions? So hopefully it answers the questions. Yeah. Okay. Right. So I think that's all. Well, in version 7, I don't see any options to use the BFD. So I don't think the BFD is available on version 7 yet. Perhaps in the future, I don't know. We'll see. Well, if there is no questions, any more questions, and then I think we can stop this webinar. Okay, again, thank you very much for coming. And then, oops. Yeah, thank you very much for coming. And then we'll see you in the next webinar. Yeah. Okay, goodbye. Have a nice day.